I've been wondering that AI systems are getting more and more robust every day, but if you notice, all of this is happening in the domain of traditional computing. But we all know that engineers, physicists, and computer scientists are working on a new era of computing, i.e. quantum computing. So, I'm here today to answer two fundamental questions, i.e. what is quantum computing and how will it enhance AI? So, let's begin. To grasp this new shift, it is crucial to understand how these computers work and how they are different from ordinary computers. I know most of the times these explanations become very geeky, and I am going to try my best to keep things as simple and crisp as possible. So, imagine classical computers as skilled jugglers, effortlessly tossing ones and zeros in the air and performing complex calculations. But now, this is what you need to understand. Quantum computers introduce quantum bits, or qubits, into the act. Like the regular ones and zeros, qubits also play a role, and this is where the magic happens. Qubits have a secret move called superposition. It's like having a third gear in addition to forward and reverse. This lets qubits be both 1 and a 0 at once. Think of it as a third coin spinning in midair, showing both heads and tails at the same time. Now, hold on to your seat, because this is where things get really exciting. With this superpower of superposition, two qubits can represent not just two scenarios, but an astonishing 4 scenarios all at once. It's like having 4 dice rolling and showing different numbers simultaneously. This turbocharges the computing process. While regular computers analyze ones and zeros step by step, quantum computers in superposition zoom through 4 scenarios in a single leap. And here's the real superhero part. Our data world is expanding faster than ever, and we are already at the point where the maximum number of transistors in a single chip can be added. The data that we generate begs to be decoded and understood. We need a computing hero with immense power to tackle this data tsunami and unveil its hidden meanings. That's where quantum computers swoop in as Cape Crusaders to save the day. If quantum computing sparks your interest, I have another surprise waiting for you at the end of the video. So make sure you watch the video till the end. But before that, let's lean into how this whole paradigm shift will affect AI. One thing is for sure, that processing speed will increase. But that's not all. There are more geeky things that I'm going to tell you about which would influence the AI industry a lot. The first thing I would like to mention is the concept of quantum entanglement, which further opens the door to exploiting intricate correlations between variables within algorithms, potentially revolutionizing how we control data. As a very valuable side gift, quantum computers possess the rare ability to tackle intricate optimization problems that have traditionally hindered classical computers. This newfound ability offers the potential for significantly improved performance of AI algorithms. In fact, the realm of artificial intelligence stands on the cusp of an evolution that defies the boundaries set by classical physics, thanks to the non-conforming nature of quantum computing. This innovative approach breathes life into exploring viable solutions to intricate problems, bolstering the potential of AI systems in a transformative manner. Additionally, the development of AI architectures becomes more streamlined and more expansive when powered by the capabilities of quantum computers. The power of quantum computers extends to the realm of calculations yet inaccessible to classical computing systems. For instance, the groundbreaking Shor's algorithm holds the key to factoring large numbers, while the efficient simulation of quantum systems further distinguishes quantum computers from their classical counterparts. The biggest banner is quantum annealing, an ingenious method that enables the resolution of problems deemed intractable by classical standards. Quantum computers' aptitude for this approach holds the potential to unlock solutions previously thought impossible, presenting a novel tool in the arsenal of AI advancement. At its core, quantum annealing draws inspiration from the natural process of annealing in metallurgy, where metal is heated and gradually cooled to achieve a desired crystalline structure. In the quantum realm, this concept is harnessed to guide qubits, quantum bits, toward finding the optimal solution to a given problem. But it's not all happy, chappy, and cool, because currently we're witnessing a new trend called save now and decrypt later. What is it? Companies around the globe are gathering gigantic loads of data. The hopes of storing now and decrypting it later open a new technological conundrum, and the idea behind this approach is to postpone decryption until quantum-resistant encryption algorithms become available. Now, what they promise is that they would be able to make this data less breachable, even in the post-quantum world. Let me explain in another way that instead of looking at your secrets right away, you save them for later. This keeps them safe from anyone who shouldn't see them. Even if someone tries to peek, all they'll find is a puzzle they can't solve. But like all good stories, there are some challenges. The special key you use to unlock your secrets needs to be kept safe too. It's like having a super secret password that only you know. You have to make sure no one else finds it. So you might be wondering that, okay, your secrets are safe and these companies are trying to protect them for you. What's the big deal? Along with these companies, malicious actors are also amassing encrypted data from their targets today, foreseeing a future where the power of quantum computing grows mighty enough to break down the walls of existing cryptographic safeguards. It's as if they're planting seeds of encrypted secrets, waiting patiently for the day when the digital landscape transforms and their efforts yield the coveted fruits of information. One survey suggests that over 400 professionals from organizations that have considered quantum computing benefits found that over half of the respondents believe that their organizations are at risk for save now, decrypt later attacks. The White House has issued national security memoranda aimed at ensuring government agencies are well versed in the looming quantum threat. These memos emphasize the need for agencies to strategize and, within a decade of the NIST standard publications, make a transition to algorithms that can stand strong against quantum advancements. So now, coming back to the banger that I promised, quantum computing is fairly known, but nobody is focusing on the developments in the world of analog computing. Digital computers took over with the advent of solid-state transistors, but a resurgence of analog technology is now possible due to factors like artificial intelligence AI, which calls for more continuous data processing. Digital computers, driven by binary code, quickly became the computing giants we know today. But the tale doesn't end there. A convergence of factors is heralding the potential revival of analog technology. Yes, we are moving back to our instincts. From transistors, we might be moving back toward machines that thrive on the subtleties of continuous voltage oscillations. Through the lens of an oscilloscope, we witness a mass oscillating on a spring, a dance of voltage mirroring the physical motion. Yet, analog computers are not without their quirks. Versatile, they are not. They excel in specialized tasks, yet their continuous inputs struggle with precision. The world of analog is one of variation. The very components that make it work can also introduce around a 1% margin of error. The key part here is that these computers are way better at single-purpose processing than digital general-purpose computing counterparts. The rise of AI, particularly neural networks, requires massive matrix multiplications, which analog computers can excel at due to their parallel processing nature. Companies like Mythic AI are exploring the use of analog chips for running neural networks, capitalizing on their potential for energy-efficient, high-speed calculations. Despite challenges, analog computing might become essential for future AI advancements. How? Well, the demand for larger neural network training will never deplete, and training one deep neural network requires the energy of a household. And this is where Mythic AI's approach shines bright. They repurpose digital flash storage cells to perform variable resistances, essentially conducting analog matrix multiplications. This novel approach offers potential advantages in terms of speed and energy efficiency compared to traditional digital counterparts. However, it also presents challenges in maintaining signal accuracy, necessitating conversion between analog and digital domains. Mythic AI's analog computing chip can perform 25 trillion math operations per second. This level of computational capability is impressive, especially given its energy efficiency, consuming about 3 watts of power. In comparison, modern digital systems, especially those optimized for AI tasks using GPUs, can perform even higher numbers of math operations. For instance, newer digital systems can handle anywhere from 25 to 100 trillion operations per second. However, these digital systems tend to be larger and consume more power, around 50 to 100 watts, compared to Mythic AI's analog chip. And the chip also costs way lesser than GPU units that cost thousands of dollars. So, just like the way our brains work, both digitally and continuously, these computers might shape the way we look at developing more powerful and robust AI systems. Subscribe to the channel for more blues from the world of AI and technology. What do you think about quantum computing? Let me know in the comment section below. I've made another video where I'm discussing how GPT-5 is a big threat. It's on your screen, be sure to check it out, and I will catch you there in a second.